Hello, in this video I'm going to show you how to solve integrals using integration by substitution. Okay, so we're going to start with these two integrals here, and they are the first two integrals from tutorial 7 on your notebook. Okay, so if we have a look at this integral here, we have a function divided by another function. We can't simplify it using algebra, so the next thing we're going to check is, do we have the derivative of one function, or is one of these functions the derivative of the other one? And if we look carefully at this function here, x cubed minus x plus 2, and we differentiate it, that gives us 3x squared minus 1, which happens to be up here. That is telling us that integration by substitution will work. Okay, so what we do is we select what our u is, and remember that's always going to be the inside function, or the one whose derivative is present. So this is going to be u. So say we write here u equals x cubed minus x plus 2. When we differentiate it, we get du dx, and as we said, that's going to be 3x squared minus 1. And now the easiest, because we do have 3x squared minus 1, the easiest step to do after this one would be, we're going to say that du, we're bringing this dx over here, is equal to 3x squared minus 1, all of it multiplied by dx. Then we come up here and we can identify that all of this and the dx, all of that is du. So we can go back to our integral. So we say this integral is equal to the integral of all of that is du divided by u, which is all of this here. And then what we have is ln u. Remember, this is u to the minus 1. Okay, if I put here, this is the same thing as u to the minus 1 du. And u to the minus 1, you integrate it, and it becomes ln u plus c, and then what we have, the final answer is ln would replace u with its real value, x cubed minus x plus 2, and then plus c. Okay, let's have a look at this other integral. Okay, we look at it and we have a function divided by another function to the power of 3. We can't use algebra to simplify it. Then we check, can we do substitution here? Okay, so we have this function here, the derivative of this one is 1, the derivative of this one here is 2x plus 2. 2 goes down, 2x plus 2. Do we have 2x plus 2 in the integral? Not really, but we have x plus 1, which is a half of 2x plus 2. So substitution will work. The inside function down here is our u, and we repeat the process. U is x squared plus 2x minus 9. We find du dx, which is going to be 2x plus 2. Now, when you don't have exactly the derivative, but you have a multiple of the derivative, the easiest way to proceed now is to find dx from the same equation. We're really doing the same thing, it's just different ways, different names for the same thing. So instead of finding du here and then finding where du is in the integral, we're going to find dx. And dx goes up here, the 2x plus 2 goes down there, so it's going to be du divided by 2x plus 2. We go back to our integral, equals integral x plus 1, we haven't done anything with it yet, divided by u to the power of 3. We can replace all of this expression with the letter u, and then instead of dx, we're gonna sub in all this expression, which is du, and at this point I'm gonna rewrite the 2x plus 2 as 2 times x plus 1. Okay, just taking the 2 as a common factor. 2 multiplies x plus 1. That means that now x plus 1 and x plus 1 cancel, and we have 1 over 2 times the integral of u to the power of minus 3. Okay, it's dividing, so we bring it up. when we do the integral, we get u to the power of minus 3 plus 1 is minus 2 divided by minus 2. These two fractions are multiplying, and plus c. So we have minus 1 over 4 u to the power of minus 2 plus c. And then the last step, I don't have space, but would be to replace the u term with the x squared plus 2x minus 9. Okay, so the important part is do the thinking at the very beginning and realize that you can do substitution, whether you have the exact derivative of the function inside the integral and you know that you can replace all of that with the u, or if you have a multiple, it's slightly easier to find the x instead, and then you will see how your x plus 1 in this case and x plus 1 cancel, so the derivative cancels and you're left with a term that is telling you what if this was multiplied by 2 divided by 2 and so on, and then you should be able to do the integral straight away. Okay, that's all. Bye.